Okay, so let me start off by thanking Matt for essentially doing all the work of organizing this workshop, and thank everybody for being here and for participating in BOINC. So yeah, BOINC is it was 20 years old sometime last year. I forget exactly when I started working on it, but the first check-in to CVS, we used CVS back then, was in late 2002. And it's I think it's pretty impressive that a you know a cutting edge technology software project has lasted for 20 years and still works and is is still being maintained. And really oddly, there is no competing product to BOINC. There are some alternatives, but nothing that does exactly what BOINC does. Let me start off by talking about general trends. We talk about this every year, but the volunteership, the number of people running BOINC, continues to decline. The peak was about 1 million. That was SETI at Home in about 2000, and then when SETI at Home switched to BOINC, it went down to about 500,000, and then it's gradually declined ever since then, and now it's down to, I haven't checked recently, but maybe 30,000. And as always, we'll talk about what we can do about that. Folding at Home, which I think has done a better job than we have of supporting their users and doing PR, I believe has somewhat more than 30,000 at this point, but they've declined too. So in general, volunteer computing is alive. 30,000 or so computers is still a lot, but we're not doing great, and maybe there'll be a resurgence somehow. Last year, I wrote a history of BOINC, both kind of technically and sociologically, and I wrote it. Ended up being quite a long essay, almost a book, and you can see that on the BOINC website. There's a link that says history. You might enjoy reading that. The BOINC software itself is, I think, doing remarkably well. It has to track various changes to the technology around it, the versions of operating systems and all the different libraries that it uses. These things are changing all the time, and change tends to break things, but BOINC has managed to keep up. Some of the kind of big items are we shifted over to using the ARM-based processors in Mac OS. And a big thanks to Charlie Fenton, who maintains the Macintosh version of the software and has done a lot of work. Each time Apple changes the operating system, they screw things up in some way, and Charlie always figures out how to fix things after that. We have, and now I have to start thanking Vitaly, who's done really the lion's share of the work in this area. We have shifted to a system called VC Package that Microsoft runs that provides compiled versions of all the dependent libraries that BOINC uses. We used to do this ourselves, and it was a big headache and a whole lot of work. But now it's completely automated, which is great. Vitaly, over the last couple of years, has also done a huge amount of work in the continuous integration features on GitHub. So when there's a check-in or a pull request is made, it automatically gets built for all the different platforms, and we can find compile errors that we would never have found otherwise. And we sort of automatically get binaries for everything. So that's been really great. The development process itself is I think working pretty well. We continue to fix bugs and to make changes. Vitaly has also done a whole lot of work going through the issues on GitHub, and of which there are still thousands. You know, these date back to 10 or 20 years ago, people wanting a feature or complaining about something. And I think Vitaly has whittled that down by a factor of 2 or so. There's still a lot of old stuff that is kind of under control now. We did have a crisis last fall with the certificate bundle, where all of a sudden BOINC clients couldn't communicate over HTTPS with some projects, and that's been fixed in a way where it'll never happen again. In terms of new features, from my point of view, the biggest thing is we added new preferences that let you set your CPU limits differently when the computer is in use versus not in use. So now you can say, use, you know, only half of my CPUs when I'm at the computer, but when I'm not, you can use all of the CPUs. Before you couldn't say that, and I think that's a real important feature. One thing that we've been working on a little bit is exploring the use of new types of computing resources in addition to home computers and laptops and phones. I think I mentioned this last year, but I was involved in a project with Suzuki to run BOINC on their in-car computers. The idea that BOINC would run when the car is parked in the garage, and these cars have, you know, 5G phone capabilities, so you can talk over the network. That project worked in the sense that we got everything running, but it did not get past the prototype stage. So there was a demo where we had 10 cars running BOINC, but the plans to run it on all of Suzuki's cars did not come to pass. Also, well, the thing that's really interesting here is that self-driving cars and modern cars in general have incredible amounts of computing power. So, for example, a Tesla has 4 of these NVIDIA chips, each one of which has multiple GPUs and 32 ARM cores, and together the computing power in a Tesla is almost a petaflop. It's like a supercomputer from just a few years ago, and there's a lot of cars, and I make the claim, I don't have any data, but I think that the majority of the world's computing power is going to be in cars fairly shortly. I made some efforts to get other car companies interested, and had a pretty good high-level call with Volkswagen. I talked to their heads of engineering in Germany, and they were interested, but it didn't go anywhere. And there's a lot of other car companies. I've heard that Mercedes-Benz is very kind of forward-looking, Tesla, of course, but I don't have contacts in those companies. We had a couple of other little projects, more in the what I would call the Internet of Things domain, home devices that have network connected, usually low power processors. There was a company that makes routers, like Wi-Fi routers for consumers, and those have a processor. And they approached us and wanted to run BOINC on them. And we got that working, or I should really say Vitaly got that working. It turned out that this router ran Linux, but kind of a weird, funky version that didn't have a normal C library. So we had to develop a special client and special versions of one of the apps from I think the SI Dock project. There was another company that makes water heaters, kind of smart water heaters. They have a processor, and we got that working. I'm not sure if they deployed it. So yeah, the Internet of Things, you know, to me it's interesting, but the processors tend to be really, really low power compared to cars. So I don't know how significant that is. Um, so that's kind of the next area to talk about is the adoption of BOINC by scientists and the number of BOINC projects. And essentially, there was a flurry of projects in the, I don't know, the 2005 to 2008 timeframe, and really almost nothing since then. As I've talked about before, the reasons for this are pretty clear. The work that a scientist has to do to create a BOINC project in the traditional way of a standalone project is really daunting. It involves all this IT stuff that almost no scientists have access to, and really the big problem is that projects have to attract and retain their own volunteers. They have to figure out how to do PR, and that's something that the average scientist can't and doesn't know how to do. And that means that the prospect of using BOINC involves a large amount of expense to do all those things and to figure out BOINC, which is really complex, with no guarantee of any computing power at the end of it, and that's a bad deal for the average scientist. Also, here in the United States, if a scientist wants a lot of computing power, there's a bunch of ways that they can get it, most of which are pretty convenient, and some of which are free. So there's this thing called the Open Science Grid, which is a bunch of Condor clusters. There's Exceed, which is run by NSF and gives scientists access to supercomputers, sometimes free. And then, of course, there's commercial clouds, which are expensive, but you know what you're going to get, and that's really, I think, attractive to scientists. If they're going to spend $50,000 in computing, they want to know how many flops they're going to get. So that led me to create Science United, which I've talked about before. The idea is that it eliminates the need for scientists to attract volunteers. They don't have to do PR, make a website. They just have to register with Science United, and they automatically get, sort of 1 over n, if n is the number of projects, of the volunteers who have registered interest in their area of science. So Science United is chugging along. It works. The number of volunteers is gradually increasing, which is nice to see, but it actually hasn't led to the creation of any new projects, I don't think, because the other factors are still too daunting for the average scientist. So that led to a new thing that I've been working on with Vitaly over the past couple of years, called BOINC Central, which, again, I think I've talked about this before. BOINC Central is a BOINC project, and the idea is that we pick out some widely used science applications, and the one we're initially working with is Autodoc Vina. And that is, BOINC Central makes versions of those apps for as many platforms as we can think of. So all the major desktop platforms, GPU versions, there's a GPU version of Autodoc. So we do all the sort of the detailed work of building for different platforms so that scientists don't have to. And then scientists can submit batches of jobs to run on these applications through convenient user interfaces, which may be web interfaces that BOINC Central provides, or it may be existing user interfaces. So in the case of Autodoc, there's a program called Raccoon, which is a Python program. You run it on your desktop computer, and it lets you, it has, it shows you these molecules, it lets you fiddle with the parameters and create the parameters for arbitrarily large batches of Autodoc jobs. And we've modified that program so that it gives you the option of running the jobs on BOINC Central. Currently, it lets you run the job on the local computer or a local cluster, or I think the Amazon cloud. And now we have a fourth option, which is run it on BOINC. And Vitaly, I think, will give a demonstration of that later on. It's pretty cool. And in the past, we've talked about this idea of a BOINC app library, kind of a collection of vetted app versions of popular programs for different platforms that can be used by other BOINC projects. And BOINC Central would also play that role. It would be a collection of app versions that are used by itself, but available for other projects. So anyway, that's what mostly what I've been working on over the past year. There's been a lot of other activity, which I'm very eager to hear about. So why don't we move on to the next speaker?
Hey, thanks, David. Before we move on, let's leave some time for a few questions. If you have any questions for David, please use the hand raise feature under reactions, raise hand, and then Alex will give people the mic one at a time. So any questions for David? David, what are the plans? Let me jump in and ask one for the app library in terms of what comes after Vina. Are you what would others in the community have to do to be able to contribute to the app library? I guess those are my two questions, and then I see some other people raising their hand.
Well, we're open to requests. Not all areas of science use kind of standardized applications. Molecular simulations, I mean, there's CHARM, there's GROMACS. We could potentially do those. Maybe, I'm not sure if there are some widely used climate models, but if people have ideas for what they think would work, contact me. And if you've already done the work of porting these apps, that would be even better.
Okay, thanks. I think next is Eric. Eric L. Alex, can you? There we go. Go ahead, Eric.
Hi. Yeah. Thank you. So I'm a bit confused about the different BOINC managers, BOINC Stats or Science United or some of the other ones you mentioned. Can you give some guidelines on which one to use, or is it a matter of personal preference?
Well, they do. So you're talking about what we call account managers, and that includes BAM, BOINC Account Manager, and Grid Republic and Science United. The first two, Grid Republic and BOINC Account Manager, you manually select your projects. And if a new project comes along, you won't run it unless you go back and select it. Science United works differently. You don't select projects, you select areas of science, like physics or astronomy or biology. There's a kind of a hierarchy of things, and your computer will automatically work for projects in those areas, including new ones that were not there when you first signed up.
Okay, so it's just a matter of personal preference as to how we want to go with that, how much control we want to have.
Yeah, you're free to use any of these account managers or none at all.
Okay, what is Grid Republic? I'm not familiar with that.
It's kind of similar to BOINC Account Manager. You can go look at it.
Okay, all right, thank you.
Oops, I muted myself. Great. I think next up is Joel.
Hi, my name's Joel. I have a real quick platform question. I've been working and trying to develop an environment around supporting Android, and I haven't seen too much Android effort in any of the or any recent releases in any of the Git repositories. Is there anyone working on that? I mean, because I see most of the stuff is in some cases a couple of years old, and they do a lot of updates on Android on a regular basis. So I wanted to take advantage of some of the enhancements that they have for instance, in their virtual environment and management of utilization of the compute resources when it's, you know, not being used. So
Yeah. We should probably postpone that. Maybe we could talk about that on the second day, because I think that's
okay.
worth discussing, and in particular the question of whether we can use the GPUs on Android phones without destroying the phones.
Wait, without destroying the phone, yeah.
So kind of in a nutshell, as far as I know, our Android version should still work with the latest Android. There was sort of a snag, which is that Google changed the rules for apps so that they're not allowed to dynamically download and run code anymore. You can only run code that is part of your original app. And of course, BOINC inherently downloads code. And that meant that we could no longer put current versions of BOINC on the Google Play Store. So
Okay.
I think there's a version of BOINC on the Google Play Store, but it's really old.
Yeah.
And I don't know if it still works. We offer a fairly recent version on the download page of the BOINC website. So you have to kind of go there manually, and you get this package file, and then you have to give permissions for it to be installed and so forth.
Yeah, did that, had a little bit of trouble getting the build going on it. So, but that's a keyboard, you know, error on my part, I'm sure.
Yeah, so maybe we can discuss Android more generally
Okay.
next week.
Thank you.
Great. Well, I think those are the questions. Last chance to raise your hand. Otherwise, next on the agenda is Alex, who's been doing some really. We have one more question from. I'm not sure how to pronounce it. I apologize. Artemio. So let's turn it over to Artemio.
Yeah.
For a moment.
This is Artemia. Yeah, thank you. So I really appreciate your great demo, David. So what I really wanted to ask you about is there any feature of grid computing and the volunteer computing? Because I know there are various kinds of cloud computing, such as Amazon Web Service and Google Cloud, and Azure also is providing the powerful computing power. But so I'm just curious, and I'm a new beginner in the grid computing. So I'd like to hearing about the grid computing prospect. Thank you. Does it make sense?
David, you're muted. David, you're still muted.
Okay, it said only the host can unmute me.
Okay, sorry about that.
I don't know exactly what the question is. Grid computing is a very broad and amorphous term. I would say that BOINC is a form of grid computing. you know, it's different from cloud because it's free for the scientist, and it's different from Condor because it uses volunteered computers. If you want to learn about how BOINC fits into the kind of the ecosystem, read that history essay that I wrote. If you go to the BOINC website, click on history, there's a section in there about that kind of compares BOINC with grid computing.
Yep, thank you. So yeah, I'm really participating in the BOINC researching and grid computing. So is there any other way to join the researching way? And I'd like to know about the researching progress. I mean, I have been working as a web developer and software engineer for past several years. So I'm really familiarized in the agile methodology, something like the Jira and software in other methodology. So so
Yeah,
I'd like to hearing about that.
yeah, there's many ways in which you could potentially help. And why don't you send me an email or post something on GitHub. So all the software development for BOINC is done on GitHub. There's a link to our repository on the website, and if you want to help with the development, that's the place to go.
Great. Yeah, I'm sharing my email on the chat. That's my
Okay,
personal email. So hopefully
Great,
I
thanks.
can. Yeah, thank you, David.
Sure.
Yep, that's all.